Assalamualaikum and hi to everyone. Here's a video presentation for our QMT 342 task that focuses on the topic waiting line. First things first, I would like to introduce our group member. Firstly, I myself, Mahadhir Hamzi bin Fauzi with student ID 2021831994. Next is Nooranisyah binti Nur with the student ID 2021874266. Last but not least is Nur Hidayu binti Rosli with student ID 2021854788. So the premise that we choose to run this research is full block. Here is brief introduction of the premise. Full block is located at lot G12, ground floor 1 Segamat Center, Jalan Kolam Air, Segamat. It operates between 10 AM to 10 PM. The number of server is 1 and our observation time from 2 to 4 PM to 3 to 4 PM. So here are 3 characteristics of queuing system, which are arrival, waiting line, and service facility. We'll go to the first one, which is arrival. The size of calling population is infinite. The pattern of arrival at the system follows Poisson distribution, which the lambda is 11 customers per hour, and the behavior of arrivals exists is patient customers. The second one is waiting line. The length of the line is unlimited, while the queue discipline is first in, first out. Now, I will pass the presentation to Nur Hidayu to proceed with the next part.
So, the last characteristic for the QA system is service facility. Firstly, is number of channel is single channel system, and number of passes is multi-pass system. So the system at a code block is single channel multi-pass system. And lastly, for the service facility is number of waiting line is a single lines. Next, I will explain about the queuing model for our group project. This is the data we got from our observation for 1 hour at code block. The result for average arrival rate, which is lambda, is equal to 11% per hour. Meanwhile, for average service rate, which is mu, is equal to 26.4% per hour. This is the QM solution for our group project. For arrival rate, which is lambda, is equal to 11. Service rate mu is 26.4, and lastly for number of server is 1. For the result we got in the decimal point. As we can see, for average number in the QLQ, we got 0.3. Average number in the system L, we got 0.71. And for the average number in the QWQ, we got 0.03. Lastly, for average time in the system W, we got 0.06. Next is solution for probability. Column for K is equal for number in system. To see the probability of the service is being used, or row, we can see at K equal to 0 and probability number in system more than K. Meanwhile, for the probability of the service is idle or P0, we can see at K equal to 0 and probability number in system equal to K. Next, I will explain about the calculation. For the first calculation is average number of customer in the system, or L. For this calculation, we can use the formula L is equal to lambda over mu minus lambda. So L we get 11 over 26.4 minus 11 is equal to 5 over 7% in the system, or in the decimal point we get 0.71% in the system. Second calculation is to find average time a customer spend in the system, or W. For W, we can use the formula W equal to 1 over mu minus lambda. So W we get 1 over 26.4 minus 11 equal to 5 over 77 hours. That and average person spent in the system, or in the decimal point we get 0.06.
Hi, I'm Nooranisyah Hamzi. Now, I will show you how to use the information of lambda and mu to get average number of customer in Q, which is LQ. Using the formula LQ equal to lambda power of 2 divided by mu multiplied with mu minus lambda, after substitute all value of lambda, we will get LQ equal to 11 power of 2 divided with 26.4 multiplied with 26.4 minus 11. Then we will get LQ equal to 25 over 84 or 0.3% in waiting line. Next, I will explain about how to get the average time a customer spent in the queue, which is WQ. WQ equal to lambda divided by mu multiplied with mu minus lambda. After substituting the value, we will get WQ equal to 11 divided with 26.4, where 26.4 multiplied with 26.4 minus 11. Then we will get the average time a customer spent in queue is 25 over 924 or 0.03 hour. Let's go to the next slide. In this slide, I will show you how to find the probability of service is being used. We can get the probability of service is being used or server is busy by divide lambda with mu, which is 11 divided 26.4. Then we will get the probability of server was busy is 0.42. Next, since there is only has one server at Google, it is easier for us to find the complement of probability server is busy, which is probability no one in the system. To find the complement of probability server is busy, we only need 1 minus with the probability, which is 0.42. Then we will get probability no one in the system is 0.58. In conclusion, the average arrival rate, which lambda at cool block 1 Segapan, is 11% per hour, and the average service rate is 26.4% per hour. Using this information, we can conclude that first, average number of customer in the system L equal to 0.71% in system. Second, average time a customer spend in the system, which is W, equal to 0.06 hour. Third, we can conclude that the average number of customer in Q, LQ, equal to 0.3%. Fourth, the average time a customer spend in the queue, which is WQ, equal to 0.03 hour. Last but not least, we find that the probability server busy is 0.42 and the probability no one in the system is 0.58. That's all from us. Thank you.